Uh, we have already discussed about Newton's third law. Newton's third law states to every action there is equal and opposite reaction. Now we are going to discuss about law of conservation of linear momentum. What is the law of conservation of linear momentum? Newton's third law states to every action there is equal and opposite reaction. Newton's second law states force is equal to or directly proportional to rate of change of momentum. The law of conservation of momentum states that if there is an isolated system, the total momentum will remain constant. That's why the definition is the total momentum of an isolated system of interacting particle is conserved. Isolated system means no external force acts on the system. Whatever force will be there, that is totally internal force. Now, to prove this, let us think of two bodies, M1 and M2. They are moving in a straight line, M1 and M2. And they are moving with two different velocities, U1 and U2. These are the two velocities. First body has mass M1, second one is having mass M2. First body is A, second body is B. But remember, U1 must be greater than U2. Otherwise, there will be no collision. U1 is greater than U2. After some time, they collide with each other. Now, when they collide with each other at this stage, obviously, B will apply some force on A will apply some force on B. The force on A due to B is FAB. Force on B due to A is FBA. Suppose this collision took place for a small time interval delta t. After that, they move as usual as if there is no collision with different velocities v1 and v2 respectively. Now let us check what happened to A and what happened to B. Momentum before collision is m1 u1 for A and m2 u2 for B. After collision, momentum of A is m1 v1 and momentum of B after collision is m2 v2. Obviously, there is a change in momentum. This is final, this is initial. Change in momentum is m1 v1 minus m1 u1 for A. Similar change in momentum for B is m2 v2 minus m2 u2. Now, time for the time during which this change in momentum took place is delta t. Here also delta t, both for the same time. Hence, force on A due to B, that is FAB, is change in momentum A, change in momentum in A per unit time. That is m1 v1 minus m1 u1 divided by delta t. Since force on B, that is change in momentum in B, m2 v2 minus m2 u2 by delta t. But according to Newton's third law, we know FAB is equal to FBA. FAB is equal to FBA minus negative. Therefore, FAB is how much? FAB, let me take the thing. FAB is m1 v1 minus m1 u1 by delta t. Therefore, FAB is m1 v1 minus m1 u1 by delta t, that is equal to minus of m2 v2 minus m2 u2 by delta t. Or I can write m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. Now delta t cancel. Now let me take m1 v1 and this is m2 v2 this side. Hence this is m1 v1 plus m2 v2 is equal to m1 u1 this side, that is m1 u1 plus m2 u2. m1 v1 is the total momentum of first body after collision. m2 v2 is the momentum of second body after collision. Hence, this gives the total momentum after collision. Total momentum after collision is equal to, this is total momentum before collision. That means momentum before after collision was or is equal to momentum before collision. That is, total momentum remain conserved. This proves the law of conservation of linear momentum. Now we will go for what is the application of law of conservation of linear momentum. That we will discuss next class. That we will discuss in next session. Let us see.